Let's start with lecture 1. It should be biomedical instrumentation, actually, not medical instrumentation, because we would like to learn also about the laboratory equipment, not just the medical equipment. Things on the horizon. No lab this week. We good. Syllabus quiz due Friday. Green quiz will be next week. Check your course D2L. Make sure that you have O'Reilly access. The 9th of every January is Law Enforcement Appreciation Day. These are links that you can go to into the IEEE Spectrum. IEEE Spectrum is a good magazine. So instead of reading scientific research papers, you can get the latest updates, information about companies, projects using IEEE Spectrum. When I go into IEEE Spectrum, I always search about a topic, and it will list for you all the latest type medical instrumentation. When you go there, you should be in a good position. List of companies. I know, guys, that you are applying and waiting for internships for the summer. I have this website is mine. So Biomedical Engineering Directory is mine. So it's a directory for biomedical companies, biomedical engineering companies. The difference between Indeed and this directory is that you can search for companies by location. In Indeed, you can go there and search for biomedical engineers and it will list all the postings, but you can't identify which biomedical engineering in which location. That is why I created this website. And I'm updating it frequently now to add as many biomedical engineering companies as possible. So double check this, and I want you to be now really active in connecting with people on LinkedIn and checking that directory. The agenda for this lecture, we talked about today we talked about the syllabus. We reviewed the format of the course. We have 2 projects. Background of instructor test. So let's see, what do you know about me? What is my bachelor degree in electrical engineering? And what was the project of my master's? My master's was about human motion analysis, the modeling. Remember the occasions of the Lagrange and the Newtonian? So that's what my master's. Now my PhD was related to bone, and it was osteoporosis and diabetes. What is the topic of my patent? I want each one of you to have a patent before you finish your degree. You will be filing a provisional patent. That's my plan. So you will have on your CV a provisional patent filing. That's my plan for it. So my patent was to accelerate bone healing for people with diabetes using biological agents. That was my patent. Now, is my patent licensed? My patent is licensed for a company called Creoso. So my plan is that if we work on a project that's instrumentation, like this one, for this class, if the idea is good, we will file a provisional patent and I have the money for it. This is my website. Now here's the thing. My website is still something that I'm trying to build for biomedical engineering. So what I did, I'm switching gears. So why I'm asking you about suggestions, I have bought a domain name called BiomedicalEngineering.info. And I'm going to create a hub for biomedical engineering. So if you have any suggestions for creating something, or you feel that there is a need for biomedical engineers to know about, or let me know. And we can work on that together. We will start with a general overview of electricity and circuit elements. It's going to be quick, and it's going to be a quick review because you've studied all of this in electronics. So let me move forward with that quickly. Before we go, let's answer some questions. What are the similarities and differences between EE and the other engineering disciplines? Let's simplify it. What's the difference between electrical and mechanical engineering? In mechanical engineering, you need to move things. So you care about forces, moments, right? Impulses. Remember all these parameters that we cared with? About electrical engineering, you need to look at the electrical current and voltage. And the most important part of electrical engineering is power consumption. And how do you power machines to work? And that's different from mechanical engineering. The other thing. And also the other thing is that the thing that we talked about, the career pathways. You can work in electrical power. You can do communication. You can do instruments, electronics. The other discipline, they have completely different setup of those. Now, where would you categorize windmill? Most of the recent applications are interdisciplinary. And that's why we want from you guys to, let's say, major in biomedical and minor in electrical engineering. Cars, all the engines now are electrical engines, correct? So we need mechatronics. We don't need classical electrical mechanical engineering anymore. So my advice to everybody is I want you guys to have some sort of knowledge of mechanical, electrical, and biomedical, and all of these things. And that's why I love biomedical engineering, because it's an interdisciplinary field. You cannot find any new application or product that is not interdisciplinary anymore. What are the major subfields of electrical engineering? We talked about them. Communication, power, electronics, right? Those are electrical engineering. Now, let's several important reasons why people study electrical engineering. We need, first of all, to create energy, correct? And you need to be able to use it efficiently, and then build systems that can utilize the electricity. So what is current? You know, we have electrical charges. What is the unit of a charge? The unit of charge is coulomb. Now, coulombs per unit time is current, which is the rate of flow of charges. That's coulomb. So the rate time flow of the electrical charge moving, in the direction that is a positive moving charge would take. So if I asked you to draw a battery, so what is the symbol of a battery?
Circle. Yeah.
This is the battery. You're talking about this.
Yeah.
So that's positive and negative.
Yeah.
But that's the symbol actually of a battery. This is a power source. The current is in the flow in the direction of the positive. So where is the positive moving in the battery and outside the battery? So if I'm going to draw an arrow, where is the arrow should hit? Inside the battery. That's how it should be. That's the current, the flow. Outside it will be the other way around, right?
Oh, I forgot about that. Yes.
The outside will be around, but inside will be this way, right? So that's the movement of the current. Okay, what is the definition of voltage? If I told you have 2 points, one of them has different potential than the other, what is going to happen to the charges? They're going to move. So there is a work that is made on the charges to move them. So the voltage is a work that is pushing the charges to different places. So the voltage is the difference of electrical potential between 2 points, and so it's like work pushing those. Now, power is the rate per unit time at which electrical energy is transferred. So let's say you bought a refrigerator, plugged it in the electricity. It's going to take current in it, right? It's going to consume power. So there's power that's not going to be returned back to the circuits, to the wires. Now that is the power. So if you bought a refrigerator that is sucking a lot of energy, that's bad, right? Because you're going to pay a lot of money for that power. So what you're paying for is the power, not the current or the voltage. And again, remember when I told you transducers, they're transforming one form of energy to another form of energy? So in the refrigerator, you're transforming electricity to heat transfer. Now, energy, the ability to do work. Remember when I told you potential, 2 points? The ability for the battery to move one electron from one port or, charge from one side to another side, that is the potential. So the potential is the energy that's pushing things in the circuit, in your circuit. And the things that we are pushing are charges, right? Now, work is joules. Remember work, which is force multiplied by distance in mechanical, right? Watts need to be connected to time because it's rate, right? Now, if you buy something and you look at the specs, if you have a larger watts, you're paying a lot of money because you are consuming that energy. What are the basic circuit laws? We have 3. Ohm's law. What is the law? V. Okay, the second one. Current and voltage. So what is the Kirchhoff current law? The sum of currents on a single node should equal to 0. right? The sum of currents entering a node should equal to 0. What is the Kirchhoff voltage law? Right, so the Kirchhoff voltage law is the sum of voltages in a closed loop should equal to 0. Ohm's law, Kirchhoff's law, current and voltage laws, those are the basics. Okay, now let me show you something. So this guy here called Charles Vest, he died, and he was the president of MIT. This fellow said that most of his career was played in the 20th century, the century of physics, electronics, and high-speed communication and transportation, which is true, absolutely true. We had a lot of physics that is used and applied into MRI, medical imaging and all of these things, and you have a lot of electronics. It's the century of electronics, and then we have speed communication, wireless communications and transportation. What do you consider the first human revolution? We were hunters, and then suddenly we changed to become farmers. That's the first one. What is the second revolution?
The wheel.
Which is the industrial revolution. We started. We actually, it's not the wheels.
Would it be like?
It's the steam engine. It's the steam engine that changed, moved us from farming into industry. Yeah. What's the third revolution? It's the healthcare revolution when we discovered penicillin and vaccinations. The death rate for humans was 40% until we got penicillin. What's the fourth revolution? It's the computer. That's it. The fifth one is AI. Now, what's the sixth one that we are now in actually? So we are in something called the hybrid humans revolution. You're going to be seeing people half human, half machines.
Yeah, girl, that's the uncanny valley.
So we are in that revolution now. And the reason why we are in this revolution is because of AI. It's because of AI actually. And quantum computing. We are in it actually. We will be able to use the robotic arms. If you're moving your hand, it's going to follow you. Yeah. So that.
Okay, I was literally thinking like I was thinking.
Oh, this is the beginning. You know what is Elon Musk is spending money on right now?
Girl, I hope nothing.
Do you see the chip that he was the brain chip? The brain chip. Elon Musk is he's saying that he is able with his company to transfer your memory into a chip. Your entire memory into a chip. No, of course not. No.
His cars blow up. I don't trust him to touch my brain.
Can you search Elon Musk chip? What? There is a name. There is a name for it. What's her?
It's the brain chip. I literally.
So that's what's it called? It has a name.
Neuralink.
Neuralink. Yes. So the Neuralink. Now this fellow from MIT who passed away. What did he say? He said after he said this, he said in the 21st century, especially our students have the privilege to live in the transition into 21st century where it is the century of biology and information, which means it's biomedical engineering. So you are actually in a time period that this is all going to come together in artificial intelligence and hybrid beings. And guys, to be honest, I honestly believe that we are no longer the smartest creatures on Earth. That's gone. Because of AI, we intelligent. Sorry, let me put it the other way. We are not the most intelligent creature on Earth. So we need to learn we need more biomedical engineers quickly to see how is that going to do this. Okay, I just want to excite you that we are actually you are in the right place in our field of study, but we need to be quick because what's the difference between the revolutions? The most important distinction between each revolution, the one that I mentioned to you. So what is the thing that makes them different now? Each one of them is a different topic, but there is a very big thing happening each time we have a revolution. Each one is getting now shorter in time. So between when we were hunters and to farming, it took us thousands of years. Between farming and industry, it took us about, 500 years. And then when we got into the healthcare revolution, it took us 100 years. The computer, 50 years. And now the AI, it just pops up from nowhere. And now we're talking about hybrid. So each time we jump, it's getting shorter. So the expectation is we need to do things fast, and people need to understand this is going to be the norm. Continuous change with new technologies and even faster revolutions in what we do. Does it make sense? And that's something I just want to make sure that we are all on the same page on that. Now, for electrical engineering subdivisions, we talked about communication systems. Why I'm talking about electrical engineering is because the instrumentation is probably 65 to 70% electrical engineering. But what is the component that you need to work most on, spend your time on? The interface. The interface between the biological system and this device. So if you are working as an instrumentation engineer, biomedical instrument, we don't expect from you to work with the power supply, right? Or work with the screens. We want from you to work with the microcontroller and the sensor. That's your job. That's the link for BME into this field of study. So communication systems, I'm going to use antennas to transmit data from the wheelchair to the Arduino, so that you need to learn a little bit about communication. Electronics, we're going to use wires and resistors and all of these kind of things. So you need to learn about those. Computer systems, the microcontroller, mainly. I don't like to even touch any general purpose computer. I need an Arduino or a Raspberry Pi, and then I can build whatever I want, special purpose, equipment. Signal processing, you've been doing this from biomechanics. Remember when you used MATLAB and you start analyzing the data? That's signal processing. Control systems, the microcontroller, the Arduino is a control system. And electromagnetics, we're not going to get into this, but if you would like to go into the antennas and the wireless communication between your device and the computer, that's where electromagnetism comes in. And this is why I suggest, really encourage, if you have the time in your space, consider electrical engineering minor. It's really, really valuable and useful. Okay, let's start with the quick. So we finished at 11:05, right? Let's stop here. So, and we will work on this on Wednesday, so that we don't cut the points or the ideas that we work with. Okay, thank you. Are you excited? I think it's good stuff to learn and invest time in. So let me stop this.